What's up, what's up, what's up? It's your boy, the network. And today's topic is configure and verify EIGRP neighbor relationship and authentication. This is section 3.19 or 319 of the CCNP route exam code 300-101, version 2.0. Let's take a look at the exam blueprint and see where we came from and where we are headed. Hashtag labeveryday. All right, this is the exam blueprint. Implementing Cisco IP routing 300-101 is the code. I've been saying that a million times. Y'all should know this by now. We just wrapped up the section describe EIGRP packet types. Now, I only did that in one video, but I'm going to do a part 2, so keep on the lookout for that. I just decided to move on because it was just a little bit more that I said I wanted to do for that video. So I'm going to do a part 2 for this video. Today we're going to do configure and verify EIGRP neighbor relationship and authentication. We're going to split this up in 2 parts as well. We're going to do the configure and verify neighbor relationships in one video, and we're going to do authentication in the next video. After that, we're going to do configuring and verifying EIGRP stubs. Today we're doing neighbor relationship. So let's go ahead and break this down. We know what configuring is. Basically install this routing protocol, right? Verifying, basically show commands. We are going to be verifying EIGRP. What is EIGRP? It is a routing protocol. If you made it this far, I'm pretty sure you know what EIGRP is, but if you don't, it stands for Enhanced Interior Gateway Routing Protocol. It's a Cisco proprietary routing protocol. I believe in 2013 they made it open source with an RFC. So basically you can use it on pretty much any router that supports it. Now you don't have to have just Cisco routers. So we're going to be configuring and verifying EIGRP, the neighbor relationships between the two. Well, why do we need to be neighbors? Why do we need to have relationships with our neighboring routers? The reason why we do that is so we can learn routes from them and vice versa. They can learn routes from us. And when we exchange these routes with each other, we find different ways and different paths to get somewhere, basically. And it makes us more efficient as a router. So let's go ahead and head over to the slides. I don't have an official definition. We just basically talking about configuring and verifying. Couple little fun facts for y'all. We're going to be talking about, obviously, configuring EIGRP with IPv4. So we have these EIGRP routers, and we configure them using an AS. And AS stands for, as you can see right there, autonomous system. An autonomous system is a collection of networks under the control of a single authority or entity, whatever you want to say. So if you look at this big circle right here, we have a bunch of routers in here, right? They're all participating in EIGRP, but they're all in the autonomous system 64,515. So we can have one company, and our AS is 64515, and all of these routers that will be participating in EIGRP sharing routes with one another. We'll have this boundary router here summarizing our routes. Hopefully, if you are an efficient engineer, summarizing our EIGRP networks and advertising it to the next router, letting them know how to navigate his way through our network. So AS numbers are needed to exchange routes between AS. Just like I said, AS numbers are managed by IANA. I'll leave a link in the description below on what that is. That's another entity that controls, how the internet works and stuff like that. It's an organization, really. And assigned by RIRs to ISPs. RIR, I believe, is Routing Internet Registry, I believe. Correct me if I'm wrong. If you know the answer to that, put it in the comments below. ISPs, you know what that is. That's an internet service provider. Like if you have Bright House, Spectrum, or CenturyLink, whatever the case may be. Internet backbone providers and institutions connecting other institutions to using AS numbers. I'm not going to try to read this all y'all. Y'all know I hate reading PowerPoints to y'all because y'all could do this reading on your own. AS numbers are usually 16-bit numbers from 0 to 65,535. Although we can support more, really you only need one AS. It's only one AS process on each router. So I don't even know why they even optimized it or made it, upgraded it so they can support more ASs. I guess if you have a huge company and you have a lot of ASs, that's the reason why. But it's only recommended to have just one process on each router. Whatever. Anyways, so this is the meat and potatoes of it. How do we configure EIGRP on a router? It's one command, but it's several keywords, a couple keywords. Router, EIGRP, and then the AS number. That's pretty much it. That starts the process of EIGRP. It is known by all the routers in the AS, and they need to be sharing the same AS number if they're going to be neighbors. Unlike OSPF, you could have router OSPF1 on one router and router OSPF 1500 on the other. They'll still become neighbors. They just have to have other things to match, like the hello timers and stuff like that. They have to be in the same network, etc. You know, OSPF numbers or OSPF process IDs, those are locally known, whereas ASs, they have to match for EIGRP routers to become neighbors. The AS number functions also as a process ID, as you can see there, used for EIGRP configuration. It's only significant to the EIGRP routing domain. So just if you go back to this right here, it's only significant to this. They don't care what it is. Over here, notice this ISP, his AS he's in BGP, but let's say he is an EIGRP router and he's in 64.239. They're not going to become neighbors because they have to match when it comes to EIGRP. So, like I said right here, do not configure multiple instances of EIGRP on the same router. If you have EIGRP run, don't put EIGRP2 on the same router. It's just going to really get funky. I've never done it before, but you just don't want to do that. That's why I'm wondering why we support so many AS numbers if we only need to configure one instance on each router. But if you have multiple ASs, that's where it'll come in handy. So we got the router ID that's used to identify each of the EIGRP routers in your network. I'm not going to read all this to y'all, but you could basically just do this in the bold, EIGRP router ID, and then put the IP address of whatever router whatever you want to name him, or whatever router ID you want to give him. If that's not done, then it'll pick the highest active loopback address. If you look at this router right here, router 2, he got a couple IP addresses, right? He's got 172.16.3.2, 168.10.9, 172.16.2.1, right? But he also has this IP address right here. Obviously, this address right here is going to be his router ID if it's up, because it'll pick the highest IP address in there. If no loopbacks interfaces are configured, it'll choose the highest IPv4 address. So it'll pick loopbacks first. There was no loopback there, so he made that his IP address. This guy right here, no loopbacks, but he has these IP addresses, so he made that 10.10 is the highest address, which was this address right here. They became his router ID. A couple verification commands. Well, obviously, this is basically the configuring command. Again, router, EIGRP, and then the process or the AS number. And then you're going to do the router ID if you want, EIGRP router ID. If you don't do this, it'll pick the highest loopback. And then if the loopback is not configured, it'll pick the highest active IP address. If you don't set any of that, it's just going to say can't start this process. And I did that in a couple videos back. I don't remember which video it was, but I'm like, why is this not working? I didn't set a router ID, nor did I have an active interface with an IP address on it. So show IP protocols is a really helpful command to know about your EIGRP setup. The process ID here, here's your router ID here. It'll tell you your K values, what's set for it. Those also got a match for EIGRP. We'll go further into it in the next slide. I don't want to do read too much of this stuff for y'all. If y'all want to pause and freeze frame it, do that if you want. We're going to go into Boson Network to do some hands-on a little bit. Anyways, configuring EIGRP, you're going to use the network command just like OSPF. You type after you do router, EIGRP, and then network, and then whatever networks you want to advertise EIGRP in. So in this case, we're advertising in the 172.16.0.0 network. In this case, 192.168.10.0 network. If you don't do no auto summary, it'll auto summarize and say, this is a class B address. We're going to be doing 172.16.0.0 network, and so on and so forth. You can do a wildcard mask with EIGRP, but if you do no auto summary, that's probably the best thing to do anyway. So again, you network, the network number, and then the wildcard mask. That's optional if you leave it on auto summary, but then you'll just be doing classful networks. So yeah, you're enabling EIGRP on those interfaces with those IP addresses. Wildcard mask, I'm pretty sure you know what those are. It's basically this 255 minus the subnet mask. That gives you the wildcard mask. And then that's what you use to say who you want or what part of the IP address network you want to advertise EIGRP in. One thing to note is that EIGRP automatically converts a subnet mask to its wildcard mask equivalent. So if you type in just 192.168.10.8 and then the subnet mask 255, when you do a show run, as you can see right here, it's going to convert it to 192.168.10.8 right here. So again, the wildcard mask is 255 minus the subnet mask that you want to advertise EIGRP in. So if your subnet mask is that, then you're just going to take 255 minus that subnet mask. That'll give you the wildcard mask. Again, EIGRP is going to do that automatically for you if you don't put in the wildcard mask. So we talked about what passive interfaces are a couple videos back, I believe in Objective 3.7. Go back to that video and we'll explain further into that. Basically, it's just an interface that suppresses hello messages, right? EIGRP has to say hello to its message to its neighbors, and then they have certain parameters that have to match before they become neighbors. But they will reply with those parameters, and if they match, then they become neighbors. So passive interfaces prevent EIGRP updates out of a specified router interface. You do show IP protocols, it'll tell you which interface is passive and also tell you which networks you're routing for, right? The default option sets all router interfaces to passive. If you do that, if you just do like default and then passive interface, just watch that video and I explain exactly more to what passive interfaces are. Here's another verification command: show IP EIGRP neighbors, and it'll tell you who your neighbors are, tell you what interface you learned them from. The hold down timer, basically the seconds remaining before declaring the neighbor down. Remember, we talked about that in the last video. If you haven't heard from your neighbor a specific amount of time, just like that old man down the street. Hey, if y'all heard from that old man, we haven't heard from him in a couple months. He might be dead. That's what the hold down timer is. Current hold down time is reset to the maximum hold time whenever a hello packet is received. So if we heard him say hello, then we reset it back to 0. And then this is the uptime. This tells you how long we've been neighbors for, basically. This is a command we use a lot at my job because we have to figure out why EIGRP interface might have bounced. That is one command that we use a lot at my job. That is along with BGP. Verifying EIGRP, again, show IP protocols. This is just a breakdown of show IP protocols. We've done this command in multiple videos. This tells you which EIGRP process is in, or AS number rather. Tells you the router ID if you want to know it, the values of the administrative distances. It tells you whether automatic summarization is turned on or not. We did a video on that as well as where we are learning EIGRP information from. So in this case, remember all these right here in the white is not in the output. Right here is what's in the output. But EIGRP routing information sources lists all the EIGRP routing sources the iOS uses to build its iOS routing table. So if he learned information from that neighbor, and that neighbor, that is our routing information sources, our neighbors, our EIGRP neighbors. Here's another verification we could use: show IP route. We are very familiar with that. That tells you the routes, AD, metric, and then the address we learned it from, how long we've learned it, the interface we learned that route from. So let's go ahead and fire up Boson NetSim. I've been bigger, starting to become a bigger fan with Boson NetSim now because it shows a step-by-step how to configure some of this stuff. Y'all know what it is when y'all see this little girl right here. This is the topology we're going to be working with, right? Branch, I believe that's branch router 1. And we got router 1, router 2. I believe we're going to make these guys neighbors as well. I believe we're going to make all these guys neighbors. I haven't even gone through this, so I'm doing this on the fly with y'all. However, I did look up. These are some of the commands we're going to be using, right? That's one I should have used in the last video, debug EIGRP packets, because when we were breaking down, I was so focused on Wireshark, I forgot about the debug EIGRP packets command. So that's another reason why I'm going to do a part 2 for the last video. This other stuff is kind of basic, setting up IP address, the network command again for EIGRP. These are the IP addressing table that we're going to set up our addresses. Task 1 says to perform initial configurations. This is basic housekeeping. I'm not going to record this stuff. I believe y'all know how to configure IP. I hope y'all know how to configure an IP address on an interface. Setting the clock rate, stuff like that. That's basic stuff. We are not going to record this. This is the meat and potatoes of it. Task 2, configure EIGRP. We're definitely going to record this part right here. Task 3 says the examine. So that's basically the verify part. So this part is the configure, verify. And then this last part is another verify. We're going to make some changes and we're going to examine the changes. So I'm going to go ahead and stop the video right here and do some basic housekeeping, setting up IP addresses and stuff like that so we can start this lab. All right, so we back. We already performed the initial configurations on task 1. All of it was just basic housekeeping, configuring IP address on the interface, inputting a clock rate, and then making sure that they're up. So basically just verifying connectivity on those guys. Task 2, configure EIGRP. This task configures and verify basic EIGRP operations. And that's basically what we wanted it to do today. So task 1 says configure, I figured it out. Backbone router 1, that's what the BBR stood for, BB stood for, to run EIGRP with an AS of 100 on the 10 network. So we're going to go to branch router, backbone router 1, and let's get out of this and do router. This is basically what you do for EIGRP, which I'm pretty sure you already know how to do, but we are doing it anyway. Router EIGRP 100 is the AS number, and he says on the 10 network. So just do network 10 quad 0, and basically we did EIGRP 100 and we're advertising on the 10 network. Step 2, configure router 1, 2, and 3, and 4 to run AS100 on the 10 network and the 172.20 network. You should see adjacencies form with neighbor routers as you configure EIGRP in the network. Before we do that, let's go ahead and run a show command. I believe we're going to run show commands later, but I want to do it right now anyway. Do show IP protocols. Once we did that, right, there it is, EIGRP 100, that's the process. Here's our K values. These are default, K1 and K3, that's bandwidth and delay. We are routing for the 10 network, and these are the default administrative distances, 90 for internal, 170 for external. And yeah, that's pretty much it. We don't have any routing information sources yet, and we're going to do that right now. So let's go ahead and configure router 1. We may or may not beat the 30-minute mark. I've been good so far, but we'll see. Router 1, configure EIGRP. So we're going to do the same thing we did on the other routers, on the backbone router. Router EIGRP 100, network 10, and that's pretty much it. We're going to do the same thing. There goes the adjacency right there. Once we do that, right? So we've configured an adjacency, and we've gotten an adjacency with this neighbor 10.2.1151. Who is that? That is, I believe, the branch router. That's the only other router that's running EIGRP right now. So there it is. See. Let's go ahead and do a show command real quick, just so we can see. I should have done this before. Show IP EIGRP neighbors, and there it is, right there. Right. That's our neighbor. It's out of serial 00 interface. The hold time in seconds is 14. We've been up for 26 seconds. If you want, you can rewind it and see it's been up for 26 seconds. But anyways, that's what it is. This is, I believe, smooth round trip time or short round trip time. I can't remember what that is. So let's go to router 2 and do the same thing. Router 2. Let me show y'all the topology again real quick. So branch router 1, we've gotten an adjacency with router 1 right here. So these two are now EIGRP neighbors. We're going to now go to router 2 and then create an adjacency between those two guys. So now we're on router 2 right here, right? And then we're going to do the same thing on router 2. Router EIGRP 100, network 10.0.0.0. And it should create an adjacency. And there it is right there. So now we have an adjacency between router 2 and router 1. We're going to go to router 3, which is located over here. Notice he's behind the frame relay cloud. Router EIGRP 100. Network, it was 100, wasn't it? Yeah, 100, right? AS 100. And then network 10.0.0.0. Should see an adjacency, I believe. Router 4, we got to do the same thing. Router 4, let's get out of this. Oh, we forgot to do the 172.20 network, so we'll have to do that on the other guys as well. So let's do that anyway. We're going to do router EIGRP 100, network 10, and also we're going to do network 170. There's the adjacency in the 10 network, .20.0.0. And let's go back and do the 172.20 network for the other guys. So on router 1, we got to do, we're still in router config mode, so we just do network 172.20.0.0. Router 2, we're going to do the same thing, right? So network 172.20.0.0. And router 3, we'll do the same thing, network 172.20.0.0. And now we've configured our network. But let's just pick one. We're going to pick router 3 and verify. Remember, we're going to do show IP, if I could type today, protocols. And you can see now we're routing for both the 10 and the 172 network. We got a couple routing information sources this time, but this is on router 3 anyway. So that's our routing information sources. Distance again is 90. That's the administrative distance. And the last update was 3 seconds and 8 seconds there. Right. Default K values for EIGRP 100. Step 3 says view the routing table on branch backbone router 1. So we're going to go to backbone router 1. How we view the routing table? Show IP routes. Verify that backbone router has EIGRP routes to the 10.2.1120 network, which is right here. We do. And the 10.2.1340 network, right here. 172.20.13 network, right there. And 172.20.24.0 network, right there. So we do have that. From branch router 1, or backbone router, I keep saying branch, backbone router 1, ping router 4's serial 00 interface, which is 10.2.134.2. So we're going to, from backbone router 1, we're going to ping router 4, where is he at? Router 4's serial 00 interface, which is right there, right? The serial is the lightning bolt, right? And the fast interface is 10 network, which I believe is right here. Maybe it's that one, I don't know. Let's see. Switch 2. So it goes to switch 2. That is the other interface. So we're going to be pinging that interface and that interface from the backbone router. Both pings should be successful. So let's hope so. Ping 10.2.134.2. That's successful. Let's go ahead and ping the other one. Ping 172.20.24.2. And that's also successful. Perfect. All right, let's go ahead and examine. Task 3 says examine EIGRP. This task involves issuing the proper show and debug command. So this is verifying EIGRP neighbor relationship. That's what we're going to be doing. We just configured them. Now we're going to verify the EIGRP neighbor relationship. So verify that each router has established EIGRP adjacencies with each of its respective neighbors. We've done that, but we're going to do it again. Backbone router 1 should have one adjacency. Show IP EIGRP neighbors. There goes that one adjacency. So where's backbone router 1? His adjacency is router 1, that guy right there, out of his serial 00 interface, and he's been up for 7 minutes and 45 seconds. Router 1 should have 3 adjacencies, so we're going to go to router 1. We're going to do a show IP EIGRP neighbors, and he does have 3 adjacencies, right? So router 1 have 3 adjacencies. Where's router 1? He has 1, 2, and 3 adjacencies. Router 2 and 3 and 4 should have 2 adjacencies. So I'm not going to do all of them, but let's go ahead and go to router 2 real quick. Get out of this. Show IP EIGRP neighbors. He got 2 adjacencies. We're going to go to router 3. I guess I will do all of them. Do show IP EIGRP neighbors. He has 2 adjacencies, and router 4, which is that guy right here, do show IP EIGRP neighbors, and he does have 2 adjacencies. Next one says on router 1. Let's go to router 1, which is that guy right there. View EIGRP neighbors. Use this output to answer the associated questions. We did that. We did show IP EIGRP neighbors, and there's our neighbors, right? No, that's backbone router, right? Yeah, we're on router 1. He's got 3 neighbors. What neighbor or neighbors does router 1 list? There it goes. That's 1 neighbor, 2, and 3. That's his 3 neighbors. What is the significance of the hold column? The hold column is basically how long we have until we consider the neighbor dead. If we haven't heard, remember from the last video, we send hellos every 5 seconds on faster links. If we haven't heard from them in 3 times the hello, slower links is every 60 seconds, right? So 180 seconds. If we haven't heard from our neighbor on slower links in 180 seconds, then we consider him dead. That's what's called a hold timer. Sometimes it's called a dead timer. That's what the significance of that is. If we do it again, you'll see, okay, 14 seconds. If we haven't heard from him in 14 seconds, he's dead. Do it again. In 10 seconds, I heard from him, he's dead. In 12, it went back to 12 because we heard from him in the hellos. If we do debug, you'll see the hellos coming in, but I don't want to do that because the screen will look all messy. Messy. From the output, can you infer the interface on the peer device that formed each adjacency? Yes, we can. That right there. We've We got a neighbor from that interface, 000. We got a neighbor on that interface and on this interface. So basically, we got two slow links, serials, and then one fast link, right? Because it's fast Ethernet, right? Let me do that again so y'all can see. Slow, fast, right? Let's see. What's the next question? How does a device running EIGRP form an adjacency with another connected device running EIGRP? Well, it forms an adjacency when both interfaces are up, when they say hello and their parameters match, like hellos and the K time, like the hello timer has to match, the K values have to match. Let's go to the answers and see. Task 3, question 3. The whole column is the number of seconds before router 1 will remove the neighbor, like we said, and 15 seconds for the whole time on faster links, and slow is 180, like we said. Oh, it says here, no, you cannot infer the interface on the peer device. The interface gives you the local interface. Oh, okay, that's my bad. So this is the local interface. That's not their interface. I think there's another show command that'll show you what interface it was learned from on the neighbor. Devices send hello packets out every interfaces. Like we said, a device running EIGRP forms adjacency configured with the same AS when it receives the hello packet. So yes, I'm sorry, the AS does have to be the same. The AS has to be the same. The hello timers has to match, and the K values have to match. That's 3 things that has to match. So my bad for steering you wrong. All right, question 4. Task 3, question 4. My dog crying. Girlfriend came home, and she just like, oh, you're finally home because he don't show me no love. All right, so task 4 on router 2, enable debugging on EIGRP hello packets. So we're going to go to router 2. We're going to go to router 2, enable debugging on EIGRP hello packets.
Pause your shit, because some shit just went on. Hold on. Almost beat somebody.
Hold on, y'all.
Ass.
All right, my bad, y'all. You know how it is when the girlfriend come home from work and stuff. But anyways, so on router 2, enable debugging of EIGRP hello packets. How can you verify router 2 is receiving hello packets on router 1 and router 4? So on router 2, we're going to enable debugging of hello packets. So I believe that's debug EIGRP packets hello. That's what I believe that is. Now they're on. How do we verify it's receiving from packets 1 and 4? Well, we just need to check the I believe the serial interface. I mean the interface. So we're sending and receiving hellos, right? Sending, received on serial 00. Who's that on? 10.2. Let's go back up, right? 10.2.1121. Who is that, right? Router 2. Let's check the addressing guide to see what that is. That's from router 1. This guy right here. That address right there. That's from router 1. The other one is we received a hello on 10 right there. 172.20.24.2. That is who? Router 4. So we received them from router 1 and router 4. That's who we're receiving the hellos from, right? That guy and that guy. That's from router 1 and router 4, respectively. All right, so task 3, question 5. Disable hello packet debugging on router 2. So we're going to do the same thing and know that. No. Now EIGRP packet debugging is off. Verify each router is configured to advertise the IP subnets present on a WAN and LAN interface. Jesus. All right, so we're going to start with, we have the WAN interface and then the LAN interface right here. WANs and LAN. All right, so let's start off with router 1. How do we verify each one is configured to advertise? I believe you just do show IP, EIGRP. I believe it's just show IP protocols. That'll tell you what it's advertising, right? There it is. That's our information sources. But we are advertising for the 10 and the 172 network, right? 172.20 network, rather. Router 3, on question 7, I'm not going to do all of them. But actually, let's go ahead and do all of them. Router 2, he wants us to do the same thing. Show IP protocols, right? Routed for networks 10 and 172.20. What's the other one we could do? I believe show IP, EIGRP interfaces? Detail? No, I believe it's just show IP protocols. Let's go to the answer. Just double check though. Show IP, EIGRP interfaces. Yep. Just like we said. It was the second time around that we got the guess right. But you could also do show IP route and show IP, EIGRP topology. So we was checking that. So we could have done this and that to verify. That is going to shows us the AS number, I don't feel like it shows us too much. But we can do show IP, EIGRP topology, and that shows us like the successor and the feasible successor. We don't have any feasible. Oh yeah, we do. That's the feasible distance. So that's our successor routes, and these are not to get there basically. I'm not going to do each one. A router 3, verify the EIGRP topology database. So let's go to router 3, which is located here. Verify his topology database. Show IP EIGRP topology, and that's his database. Use the output to answer the associated questions. How many successors does router 3 have to the 10.2.1120 network? So that's this guy right here, one successor. What is router 3's feasible distance to 10.1.12? That's his feasible distance. Feasible distance is right there. What is the difference between the reported distance and the feasible distance, right? The reported distance is how far it is to the next EIGRP router, to a specific network. Okay, so you got to say you got a specific network, right? The next router, the next hop will give you the reported distance. He's reporting to you how far it is. The feasible distance is how far it is to get to all the way to that network. So let's say you got router 1, 2, and 3, right? The full feasible distance would be all the way to router 3, right? The reported distance is how far it is to router 2, if that makes any sense. I always remember full and feasible. That's how I remember it. And reported is the router that's right next to. He's reporting to you how far it is to that other network, which is the end of router 3. Hope I explained that right. I'll put some definitions below on what those are. But if you've made it this far with your EIGP studies, I'm pretty sure you know what those are. Anyway, on router 1, view the routing table. Let's go to router 1, which is located here. View the routing table. Show IP route. Compare the information inserted in the IP routing table with the information on the EIGRP topology database. What value of the EIGRP topology database does a device insert into the routing table as the metric for any given route? The value would be the metric. That would be that right there. Examine EIGRP changes. This task involves EIGRP as it recalculates to a network. On router 3, let's go to router 3. Display all learned links on the EIGRP topology database. Use the output to answer the associated question. How many total links to the 10.2.1120 network? I believe that show IP EIGRP topology. I think it's all links. Yep, all links. How many total links to the 10.2.112 network? 1, 2. Where are they at? Serial and then a fast interface. So serial and a fast interface. That's how we could tell. How many feasible successors to the 10.2.112 network? 10.2.112 network. This is a feasible successor, and that is a feasible successor. He has one successor, though, which means that's the best route. What are the network addresses and feasible distances to those networks router 3 would have to query for if the LAN link between 1 and 3 were to fail? Between 1 and 3 were to fail. The LAN link is this one right here. If that one was to fail, what are the network addresses and feasible distances to those networks router 3 would have to query? Not too sure. Let's go ahead and take a look at the answer table. So yeah, 2 total links to the network exists. 1 successor exists. However, 0 feasible successors to the 10.2.112 network exist. A route must have a reported distance less than the feasible distance to become a feasible successor. So I believe we're going to take something down to test that theory. Anyways, if the LAN link between router 1 and 3 would have failed, this guy right here, router 3 would have to query for routes for 10.2.115 and 10.2.112 and these networks. The feasible distance for both Class A networks is that. And the feasible distance for the 172.20.13.0 network is 28.160. So that's the feasible distance. Remember, FD is feasible distance. Issue a trace route command on router 3. So we're going to go to router 3. We are on router 3. Trace route to branch our backbone router 1 serial 001 interface, which is 10.2.115.1. On router 3, we view debugging. So we did a trace route to backbone router. So we did a trace route from this guy to that guy. On router 3, view debugging information about update, query, reply, and ACK packets. Believe we could do debug. I just learned this before I started even running this lab. EIGRP packets terse. This is going to display all EIGRP packets except hello. So update, query, reply, and ACK. So now we're going to view all of them on switch 1. Disable the FA02 interface to simulate unplugging a network cable. Quickly return to the console of router 3. So we're going to go to switch 1, disable FA02, enable, configure terminal, interface FA0/2, shut that guy down, and we're going to go back to router 3. Boom, router 3. And now we should see some packets fly. Come on, buddy. There they go. There goes the packets. FA0 went down, and we got a couple interfaces. Some replies, some acknowledgments. Basically, we're trying to recalculate another way to get to the backbone router. Observe the debug output on router 3. We're doing that. After a few moments, interface 10 on router 3 will go down, which it did right over here, causing EIGRP to query its neighbors for routes through FA10 with no feasible successors. You can verify this process by observing router 3 sending and receiving query, ACK, reply, and updates to its neighbor 10.2.134.2. Who is that? I believe that's this guy right here. So he's sending all of these queries like, hey, this network went down. Do you have another way to get there? And there is no feasible successor. On router 3, view the EIGRP topology database again. What are the new feasible distances for the networks you listed in the first step of this task? So we are going to do a show IP EIGRP topology, new feasible distance. Here goes our feasible distances right here. We wanted to look at this one specifically. It's now 268.4416. It is now 217.2416. That was recalculated, as you can see. All right, issue a trace route on router 3 to the backbone router on serial 00 interface. First, it took 2013.1.0. 2013.1 and 10.2.115.1 to get to the backbone router. First hop was 172.2013.1, right? Who was that? So the first hop was router 1, from here to there, and then he went to the branch router. So he went from here to there. He actually took that and then went that way. And now if we do a trace route to the same location, he takes all these other hops. 10.2.134.2. Who is that? Router 4. So he went from here to router 4. Next hop is 172.20.24.1. That guy right there. So he went to router 2. So he went from router 3 to router 4. Then he made it to router 2, which I believe he took the local area interface. He went from here. No, he didn't go to switch 2, did he? He went to router 2. And then next hop is 10.2.112.1, the serial interface of router 1. So we went from here, 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 and then the serial interface of router 1, which is there. And then the last one is 10.2.115.1, which would be the backbone router. So he used to just go this way, and then that network went down, and now he had to go all the way here just to make it to the backbone router. Okay, on switch 1, enable the FA02 interface. So we're going to go back to switch 1 and re-enable that guy. So we're going to do a no shut. Let's go back to router 3 and watch those. Here we go. So now everything went up. Now we're recalculating EIGRP. On router 3, you should observe the FA10 go up, and we did that right here. It went up. We got a new adjacency as well. So there's the adjacency. There's the FA0 going up. FA10 going up. Where is that? The FA10 go up. I need to stop this so y'all can see. FA10 went up here. EIGRP got re-enabled right here. The adjacency is being restored after several more exchanges, update, and ACK packets. EIGRP advertises its new better route to 10.2.112 and exchanges information with its new neighbor. Then they want us to turn off debugging. The easy way to do that is just U/all, U space all, which is basically short for undebug all. So now we just turned off debugging. And that's the end of that lab. Whew, that was a breather, y'all. That's my contact information. I'm sorry if I kind of confused y'all, but hopefully that kind of straightened out configuring and verifying EIGRP. Next video, we're going to do configuring EIGRP authentication. I believe I have a custom lab for it. No, we're going to do Boson Net Sim again. If you like this video, please comment, like, subscribe to the network.